Hello everyone, welcome to Brain Blitz Audios. Today in this episode of Cbse board exam, we'll be continuing our discussion of the sample paper for 2021 released by Cbse for mathematics. This is the 5th video in this series, and today we'll be taking up questions of section 3 of the sample paper. Let's begin where we left off. The first question here is question 23. And this question has two parts. Here's the first. Find the integral of 1 by cos square x times 1 minus tan x the whole square dx. How do you solve this question? For 2 marks, to solve this question, what we're going to do is we're going to write the integral first. Integral dx divided by cos square x times 1 minus tan x the whole square. And we will now convert this equation to the form integral sec square x dx divided by 1 minus tan x the whole square. That is because 1 by cos square x is equal to sec square x. Now, how do we further solve this equation? We will use substitution in order to solve our question. So now we'll consider y as sec square x sec square x. No, that is wrong. What we're going to be considering is y equals 1 minus tan x. And when we're doing differentiation, you will get minus sec square x as dy by dx. So minus dy is equal to sec square x dx. So now we'll replace the numerator and denominator in terms of y. So sec square x dx becomes minus dy divided by 1 minus tan x the whole square becomes y squared. Now the minus, since it's constant, is taken outside the integral, and inside the integral 1 by y squared becomes y raised to minus 2 dy. Now we've reached this step, and for all of these, differentiation and substitution, you get 1 mark. Now let's write minus of integral y raised to minus 2 dy using integration. Now over here, it's the normal integral x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. So this becomes y raised to minus 1, minus 2 plus 1 is minus 1, divided by minus 1. And then outside there's already a minus. So y raised to minus 1 is 1 by y. So minus of minus 1 by y, that makes the integral as 1 by y. And let's put in the value of y, that is 1 by 1 minus tan x. And then in the end, you can just add a plus c as the constant. And all of this will fetch you another 1 mark. So the integral of 1 by cos square x times 1 minus tan x the whole square is equal to 1 by 1 minus tan x plus c. Let's move on to our next question. The OR question is to evaluate integral 0 to 1 x times 1 minus x raised to n dx. So in order to solve this question, we're going to use the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So our original expression is integral 0 to 1 x times 1 minus x raised to n dx. We'll just substitute 1 minus x in the place of x. So that becomes integral 0 to 1 1 minus x times 1 minus 1 minus x, the whole raised to n dx. Now, over here, 1 minus 1 plus x becomes just x. So inside the big bracket, the square bracket, the term will become x. And so we can write the integral as integral 0 to 1, 1 minus x times x raised to n, and which we can multiply towards the bracket to get integral 0 to 1, x raised to n minus x raised to n plus 1 dx. And these two steps will fetch you half marks. Now, let's split the integral. So finally, you'll get integral 0 to 1, x raised to n dx minus integral 0 to 1, x raised to n plus 1 dx. And now you just use the formula integral x raised to n dx and apply the limits in order to get your formula. So now what happens is that yes. Now we're going to integrate the two integrals. So the right-hand side will now become x raised to n plus 1 divided by n plus 1 from the limit 0 to 1, and x raised to n plus 2 divided by n plus 2 from 0 to 1. And now, since they have the same limits, it's okay to combine them. So x raised to n plus 1 divided by n plus 1 minus x raised to n plus 2 divided by n plus 2 from 0 to 1. And having written both of these steps, that will give you 1 mark. And now let's substitute the limits here. So when you're substituting 1, it becomes 1 divided by n plus 1 minus 1 divided by n plus 2 minus 0 by n plus 1 plus minus 0 by n plus 2. The right-hand side becomes 0, and the left-hand side becomes, not the left-hand side, the left bracket becomes 1 by n plus 1 minus 1 by n plus 2, which now what we're going to do is we're going to take the LCM, which is n plus 1 times n plus 2. So the numerators will become n plus 2 minus, in bracket out, n plus 1. So that becomes n plus 2 minus n minus 1 divided by n plus 1 times n plus 2. So therefore, the final answer is 1 by n plus 1 times n plus 2. And writing this final answer will give you half marks. Let's look at question 24. Find the area of the region bounded by the parabola y squared equals 8x and the line x equals 2. So the first step is to draw the graph, because if you draw the graph, then you'll make sense of what you want to integrate. So when you draw the graph of y squared equals 8x and x equals 2, you see that the integral lies along the x-axis from 0 to 2. Now let's name the closed region as AOBC, and the formula is area of AOBC is 2 times the area of AOC. So as you can see here, this area is the same as that area because the curve here is symmetrical. So therefore, our required area is 2 times 0 to 2 y dx. And the function y with respect to x is 2 times integral 0 to 2 root 2 x dx. So 2 times root 2x into dx. The reason is when you take y squared equals 8x, then y becomes the root of 8x. 8 is 2 root 2, so 2 times root 2x. Now we can take 2 root 2 outside, so 2 times 2 root 2 into integral 0 to 2 root x dx. That is equal to 4 root 2 times integral 0 to 2 x raised to half dx. And over here, this step will give you 1 mark. Now let's move on. On integration, you'll get 4 root 2 times x raised to 1 plus 1 by 2 is 3 by 2 divided by 3 by 2, and the limits are 0 to 2. Now that will be equal to 4 root 2 times 2 by 3 taken outside, x raised to 3 by 2 from 0 to 2. This step will give you half marks. And now let's multiply the terms outside the bracket, so that becomes 8 root 2 divided by 3, and inside you'll get 2 raised to 3 by 2 minus 0 raised to 3 by 2, which is 0. So 8 root 2 times 2 raised to 3 by 2 is 2 times 2 raised to 1 by 2, that is 2 root 2 divided by 3. So that is 16 into 2. Root 2 times root 2 becomes 2. 8 times 2 becomes 16 divided by 3. And so the final answer becomes 32 by 3 square units. Remember, we have to find the area here of the graph, so you should write square units at the end. And writing this answer will fetch you another half marks to complete 2 marks. Let's solve the final question. The final question is to solve the following differential equation. dy by dx is x cubed times cosecant y, given that y of 0 is 0. So over here we have dy by dx equals x cubed cosecant y. We're going to change this expression in terms of y on one side and x on the other. So it becomes dy by cosecant y equals x cubed times dx. Cosecant y is 1 by cosecant y is equal to sine y. So sine y dy is equal to x cubed dx. On integration, you will get integral sine y dy equals integral x cubed dx. All of this will fetch you half marks. Now all we have to do is integrate. And when you're integrating, the left hand side becomes cos minus cos y, because integral of sine x dx is minus cos x, so integral of sine y dy is equal to minus cos y. On the right hand side, it's the integral of x cubed, that is x raised to 4 divided by 4 plus c. That becomes our equation 1. And this step also fetches you 1 mark. So it's a very important step. Now what we're going to do is we're going to put x equals 0. So that means y will also have to be equal to 0. So at this stage, it becomes minus cos of 0 equals 0 raised to 4 divided by 4 plus c. Cos 0 is equal to 1, and the right hand side will be equal to just c. So c is equal to minus 1. Now we'll put c equals minus 1 in the equation number 1. That will make it minus cos y equal to x raised to 4 divided by 4 minus 1. Now the step is to multiply minus 1 to both sides. And when we do that, you will get the final equation as cos y is equal to 1 minus x raised to 4 divided by 4. And that is our final answer. We hope you found this episode informative. For more of our useful videos, don't forget to subscribe to our channel, Brain Blitz Audios. So, until the next webisode, take care, stay safe, bye-bye for now.